In this lesson, chapter 1.5, we're going to talk about the ways that two lines can intersect. Well, there are three ways. First of all, two lines can have 0 points of intersection. That occurs when the lines are parallel and don't touch. Like these two lines. They're parallel and they'll never touch. They have 0 points of intersection. Well, looking at these two lines, we can say they have the same slope. For sure they have the same slope. And also they have different y-intercepts. The y-intercept here is down here, and this y-intercept is up here. So 0 points of intersection are going to have the same slope, but different y-intercepts. Well, let's look at 1 point of intersection. Anytime two lines don't have the same slope, they're going to intersect exactly once. These two lines have different slopes, and they intersect exactly one time. That's another possibility. And the third one is you could have infinite points of intersection. So I want you to imagine that there's a red line graphed right over top of a blue line. And they are identical to each other, and so every point is on both, and so they have an infinite number of points of intersection. And how can you tell that? Well, they have the same slope, clearly, and they have the same y-intercept, clearly. So, in summary, if two lines have the same slope but different y-intercepts, there are no points of intersection. If they have different slopes, there's 1 point of intersection. And if they have the same slope and the same y-intercept, there are an infinite number of points of intersection. Alright, well, the first question we're going to do asks us to determine the number of solutions to this linear system of equations. So what we're going to do is figure out which of those three situations we have. The first line has a slope of 3. The second line, after isolating for y, we see it has a slope of -2/3. Well, these slopes are different, and since the slopes are different, therefore, there's only one solution. And notice how we got this slope. We figured it out to be -2/3. We did that by isolating the y. Isolate y, divide everything by 3. We get a slope of -2/3 because that's this coefficient. Well, let's look at our next question. Our next question asks us to, without graphing, determine the number of solutions to this linear system. Well, the way we're going to do that is, once again, to find out the slopes. Are the slopes the same? Well, I'm going to isolate for y in this first equation. We're going to subtract 3x from both sides. We're going to divide both sides by 4, recognizing that this is the this coefficient here is the slope. The first line has a slope of -3/4. And then we're going to figure out the slope of the second line. We're going to do that by isolating y. So, isolating y on the left-hand side, we can do that by subtracting 36 from both sides. And then we can multiply both sides by -1. And then we can divide both sides by 12. And we get y equals -3/4 x plus 3. And right away we notice we have the same slope in both situations. We have a slope of -3/4 here and a slope of -3/4 here. Well, now we say because the slopes are the same, we're going to compare the y-intercepts. And if the y-intercepts are the same, there's an infinite number of intersection points. But if the y-intercepts are different, then there are 0 points of intersection. Well, looking at them, we see in the first equation, after isolating for y, we got a y-intercept of 3. And in the second equation, after isolating for y, we got a y-intercept of 3. So we can say that since the y-intercepts are also the same, therefore there are an infinite number of solutions to the linear system.